Hello everyone, welcome to Math World. This video is to discuss paper 3-2 for May-June 2025. Okay, so let's start. Number 1, solve the equation. Give your answer correct to 3 decimal places. Okay, so first of all, I will rewrite the question. Okay, so from here, I will just move the denominator to the right side. Then it becomes ex plus 2e minus x equals to 4 times ex is 4ex. 4 times minus 3 is negative 12. Okay, then from here, since you have e of negative x, alright, therefore, we will just eliminate this term by multiplying ex to the whole equation. Then ex times ex, for the first term, it will be e to x. Right, because we have a formula, ea times eb, that is ea plus b. Therefore, ex times ex is ex plus x, which is e to x. And same goes to the second term, e minus x times e positive x, that is e0. E0, it will be 1. Therefore, I will be getting 2 for the second term. And the right side, first term, it will be e to x, and this is 12ex. Okay, then from here, I will just move all the terms to one side. That means I will be moving the terms on the left hand side to right side. Then I will be getting 3e to x minus 12ex minus 2 equals to 0. Okay, and now here, I will let u equals to ex. Therefore, you will be getting 3u squared minus 12u minus 2 equals to 0. And this is a quadratic equation. Now, I can't factorize this quadratic equation. Therefore, I will be using the quadratic formula. The quadratic formula, ax squared plus bx plus c equals to 0. Then your x will be minus b plus minus square root of b squared minus 4ac over 2a. Okay, then now using this formula, you will be getting a equals to 3, b equals to negative 12, c equals to negative 2, and hence my u is going to be minus of minus 12 plus minus square root minus 12 squared minus 4 times 3 times negative 2. Then over 2a. Okay, then from here, you will be getting the answer 4.1602. Now, since the question asking for 3 decimal places, and now I'm just getting my working. Okay, so I will give 4 decimal places. And the other value will be negative 0.1602. Now, substitute this u into your ex, because you need to find x. So, 4.1602 or equals to ex, or ex equals to negative 0.1602. We know the exponential graph is always above the x-axis. This is your exponential graph. Okay, therefore, the second value does not have any solution because the e is negative. Now, to eliminate the e, we are taking ln both sides. So here, x equals to ln of 4.1602, and then you will be getting 1.426. So my final answer for this question is 1.426. So this is the solution of question number 1. Question number 2. Expand 6 minus x times 1 minus 2x to the power of negative 3 over 2 in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So now, the first term is with degree 1. We just rewrite. Okay, but the second term, I have to change to the general form. So basically, the general form is 1 plus x degree n equals to 1 plus nx plus n minus 1 over 2 factorial x squared, and so on. Alright, so the condition for you to use this formula is it must be 1 and is a plus. So here I got 1 and I get the negative. Therefore, I will change to negative 2x. 1 plus negative of 2x. That means now my x here becomes negative 2x. So I will change accordingly. So now just apply the formula. It will be 1 plus n is negative 3 over 2. My x is negative 2x plus, and the question asking for x squared. So the next term is n is negative 3 over 2. Then I need to minus 1 from negative 3 over 2. That is negative 5 over 2 over 2 factorial. And then my x becomes negative 2x and you squared it. Okay. Then from here, you will be getting 6 minus x times 1. Now, negative 3 over 2 times negative 2x, that is plus 3x. And then the next term is going to be plus 15 over 2x squared. Okay, so next step is just to do expansion. So 6 multiplied by the square brackets, then followed by the minus x multiplied by the square brackets. So from here, I will be getting 6 plus 18x plus 45x squared. And then when minus x multiplied by the square brackets, it will be negative x, negative 3x squared. Now, negative x times the x squared is already x cubed. And as per requested in the question, we just need to solve the question up to x squared. Therefore, the last term, I will just ignore it. Okay, and now simplify all the terms. You will be getting 6 plus 17x plus 42x squared. So that will be our binomial expansion. Now B, state the set of values of x for which the expansion is valid. Okay, so for this expansion, the set of x values, go back to the notes. So since this is an expansion, so just for information, this expansion is valid when, okay, look at here, plus x. So when modulus of the x is less than 1. So this is the concept. Okay, so from here, what I need to do is, I will refer to this because we did the expansion for this, alright? So I have to take the modulus of this term and less than 1. So I will write modulus of negative 2x less than 1. So we know that after modulus, it will be always positive. So this becomes 2, or I will say modulus 2x is less than 1. Therefore, the 2 can be taken out. And at last, my modulus x is less than half. Okay, so this will be the set of values of x for which the expansion is valid. Okay, next question number 3. On an Argand diagram, shade the region whose points represent the complex numbers z, which satisfy the both inequalities. So here we have two inequalities. The first one is modulus z minus 3i less than or equals to 2, and the other one is the argument. Okay, so the first one I have to express in the general form, whereby this is a circle because you only have one modulus. And from here, the general form of a circle is basically modulus of z minus the center. Okay, this is the center coordinates, then less equals to, or I would say it is, you can write equals to r or whatever, right? That means from here, the center is with coordinates AB, and then the radius is r. This is a general form of the radius inequality. Then I will change to the similar form, that will be 0 plus 3i. Okay, so which means my center of the circle is basically 0, 3, and then the radius is 2. Okay, the other one, this is argument. So whenever argument, that means this is a line segment. And again, I need to write down the reference point. Therefore, you just change to z minus bracket 1 plus 2i. Okay, Then from here I will say that my reference points now is with coordinates 1 and 2. So then I will just draw the Argand diagram. Okay, this is imaginary axis and center 0, 3, 1, 2. Okay, so this is my real axis. Here is 0. Since the center is at 0, 3 and then radius is 2, that means I need to draw up to 5. Okay, center is here, 0, 3. Radius is 2. So going up 2 units, then going to the left and right side 2 units. So 2 units, going down 2 units, and going to the left side 2 units. So then join this to get a circle. Okay, so just try your best to draw a smooth circle. Okay, then now the other one is 1, 2, the point. So 1, 2, x is 1, y is 2, that means it's over here. Okay, so now I need to draw the angles first. Pi over 4 is basically 45 degrees. Okay, so we know that in a right angle triangle, if here is pi over 4, that means the opposite and the adjacent side should be the same, because we know that tangent pi over 4 is 1. Okay, tangent pi over 4 is 1. So tangent is opposite over adjacent. So these two values will be 1. Or probably I can say these two are the same value. Okay, are the same values, a over a. Therefore, you get 1. So which means now here, okay, I have to draw 45 degrees, or probably you can just see here. Here is 1 unit. Okay, that means it will be 1 unit over here. So left here, horizontal 1 unit, upper is 1 unit, vertical is 1 unit, which means it will be touching this point. Okay, 2, 3. And there is an equal sign. So here is going to be pi over 4. Right, so the vertical and horizontal will be 1 unit for each. And now for the 3 over 4 pi, 3 over 4 pi is basically here, 3 over 4 pi. This is 3 over 4 pi, and then this side will be 1 over 4 pi, so that it will be 1 pi. Okay, so I will use back the same method to draw 1 over 4 pi from the other side, that means from here. Okay, so again use the same method. Since I know that here is 1 unit, okay, then this is already at 2, so I will go up 1 unit, then this will be my pi over 4. Right, it's a straight line, so this is pi over 4. So when here is pi over 4, that means this is 3 over 4 pi. Okay, so this is how I get it. Now, what I need to do now here is you can accept the angle between pi over 4 and 3 over 4 pi. That means it's in between these two green lines. Okay, and at the same time, when you look at this this inequality, it is a modulus, which means it is a circle, but the distance, okay, this is a distance, the modulus means distance, less equals to 2. When it is exactly 2, then it will be on the orange line. That is the circumference of the circle. But it is less than 2, that means it's inside the circle. So we need to fulfill these two conditions, whereby it is inside the circle and also in between these two green lines. So obviously your region will be this part. Okay, so this is our shaded region. Okay, done for this question. Probably you can just label this, right? This is modulus of z or z minus 3i equals to 2. And then this is argument equals to pi over 4. And then this line will be argument of the complex number equals to 3 over 4 pi. Okay, so done for this question. Next question, number 4. Solve the equation for the x between 0 and 180 degrees. So 3 cot tangent x minus 4 cot 2x equals to 3. Okay, so I will change the cotangent x into tangent x. We know that cotangent x is 1 over tangent x. So when you multiply 1 over tangent x by 3, that is basically 3 over tangent x. Same goes to the 4 cotangent 2x. This is 4 over tangent 2x equals to 3. Okay, and now since you have tangent x and tangent 2x, I will change my tangent 2x. So we have a formula here. Tangent 2x is basically 2 tangent x over 1 minus tangent square x. That is the double angle formula. So it becomes 3 over tangent x minus 4 divided by 2 tangent x over 1 minus tangent square x. Okay, so simplify the second term first. So move up the denominator. So the denominator is 1 minus tangent square x. So I will move it up. It becomes 4 bracket 1 minus tangent square x over 2 tangent x equals to 3. So the 4 and 2 can be simplified. It becomes 2 in the numerator. And since both terms also are divided by tangent x, I will just times the whole equation by tangent x. So when you multiply the whole equation by tangent x, basically the first one left 3, and the second one is just a numerator. And then the term on the right side becomes 3 tangent x. And now do expansion. That will be 3 minus 2. The minus 2 times the minus tangent square x becomes plus 2 tangent square x. And then equals to 3 tangent x. Okay, so rearrange to get a quadratic equation. So I will keep the terms on the left side. Then you will be getting 2 tangent square x. The 3 tangent x will be moved to the left side, becomes negative 3 tangent x. Then the first two terms, 3 and minus 2, becomes plus 1. Okay, and now you are getting a quadratic equation in terms of tangent x. So this can be factorized into tangent x minus 1 times 2 tangent x minus 1 equals to 0. Therefore, product of two terms equals to 0, which means one of the terms must be 0. So I will say maybe, okay, tangent x minus 1 equals to 0, or 2 tangent x minus 1 equals to 0. Then you will be getting tangent x is 1, or tangent x is half. Okay, so now look at the interval. The x is from 0 to 180 degrees, which means it is in the first two quadrants. So I will draw the quadrant diagram for each. Okay, so when tangent x equals to 1, that means it is in first quadrant. Tangent x is half also first quadrant, because first quadrant is positive for all functions and also third quadrant for tangent. But then our x is from 0 to 180 degrees. That means it's just first two quadrants. So I should get these two angles. So now my angle x equals to arctangent 1. Because I only get one value here. Therefore, it is 45 degrees. Okay, and x equals to arctangent half. Then you will be getting 26.6 degrees. So this will be my solutions. Okay, let's move on to next question, number 5. The square roots of -1 minus 4 root 5i can be expressed in Cartesian form x plus iy, where x and y are real and exact. Exact means no decimal. By first forming a quadratic equation in x or y, quadratic means the equation with x degree 4. Okay, or I would say the equation with the highest degree of 4. Okay. So by forming that, find the square roots. Square roots means more than one answer in exact Cartesian form. Okay, so basically the question asking for square root. So let square root of -1 minus 4 square root 5i. We can just follow this equals to x plus iy. Otherwise, you can just follow the imaginary part, which is minus. Okay, so we have two options now. So now to solve this, okay, I will just square both sides. This is what I'm going to write in the next step. So square and square root becomes degree 1. So I will just rewrite my complex number. Then you will write x plus iy squared. Now do expansion for the quadratic. It will be x squared plus 2xyi plus I squared y squared. Okay, when do expansion. And remember, I squared is -1. Okay, so the last term I will change to -1. So since this is -1, okay, so this is -1. Okay, -1 times y squared is -y squared. And this term without I, therefore I will group it together with x squared. That will be my real part. Then I will write plus 2xyi. Okay, so then now basically you are getting equal complex number. Left side is a complex number, right side is also a complex number. So use the concept of equal complex number and do the comparison, which means the real part -1 equals to x squared minus y squared, and then the imaginary part -4 square root 5 equals to 2xy. Okay, so from here I get my y as a subject. Okay, so the 2 and 4 will be simplified. So which means my y becomes -2 square root 5 over x. This is my second equation. And the question says forming quadratic equation in x or y, which means now I substitute second equation into first equation. So I will write -1 equals to x squared remains minus the y will be replaced by -2 root 5 over x. Then you square it. Okay, then now do expansion. So -1 equals to x squared minus square of -2 root 5. That is 20. Then over, bring the square in. It will be over x squared. And now here, since you have a denominator of x squared, multiply the whole equation by x squared. So you will be getting minus x squared equals to x degree 4 minus 20. And rearrange this so that it will be x degree 4 plus x squared minus 20 equals to 0. So this is the quadratic equation that has been mentioned in the question. Now, to solve this, okay, you can just write let u equals to x squared. Therefore, I change to quadratic equation. I'm getting this quadratic equation. So now I factorize this quadratic equation by u minus 4 times u plus 5. So my u equals to 4 or u equals to 5. But then don't forget we are solving for the x and y. So now replace x squared equals to 4 or x squared equals to, this is -5. Okay, because u plus 5 equals to 0. So x squared is a is a non-negative value, okay, because your x and y are real values, real numbers, so this one no solution. So therefore my x will be plus minus 2. So when I get 2x, now I need to substitute into my second equation to get my y. Okay, so from second equation, my y is negative 2 root 5 over x. So when x equals to positive 2, my y is negative 2 root 5 over positive 2. That is minus square root 5. But when my x equals to negative 2, my y is negative 2 root 5 over negative 2. That is positive square root 5. And don't forget, my square root is x plus iy. Therefore, square root minus 1 minus 4 root 5i. This is going to be x plus yi. So 2 plus minus 5i minus 5 root I. Minus root 5i. So it will be 2 minus square root 5i. And the next one is minus 2 plus square root 5i. Okay, now question number 6. By sketching a suitable pair of graphs, show that the equation modulus x minus 2 equals to 2 sine half x has only one root in this interval from 0 to pi. Okay, so let y equals to x minus 2. Ignore the modulus sign first. So to get this straight line, I get 2 points. When x equals to 0, the y is negative 2. And when the y equals to 0, my x minus 2 is 0. That means my x is 2. Okay, so I get 2 points. Then now, when x 2 sine half x, okay, so then from here, okay, but then we need to show that there is a root between 0 and pi. I think better don't use y equals to 0 because otherwise I have to figure out where is my 2 instead of pi. So probably I will just replace the x by pi, okay, to get the endpoints. So my y is going to be pi minus 2. So when you calculate, this is actually 1.14. Then this will be better. Okay, so maybe this is pi, okay, because you need to draw 0 and pi. So 0 and pi. Let's say here is pi. Okay, so we know that pi is 3.14. Okay, so here y equals to negative 2. So 1, 2. Negative 1, negative 2. So when x 0, your y is negative 2. When x goes to pi, 1.14. 1.14 is somewhere here. Okay, so I should draw it. Right? Then when I do reflection, it will be reflected to 2. So it's a straight line. Okay, so this is your y equals to modulus x minus 2. Now, another one is 2 sine half x. Okay, so when sine 1x, okay, just for your information, let's say we need to sketch sine x. This is our sine graph. Here is 2 pi. Here is pi. Okay, so when sine half x means that we are sketching half of this graph. Okay, from 0 to pi. So when 0 to pi, supposedly here. But now I'm just sketching half of this graph. Half of this graph, which means I need to know my half pi. This is my half pi. So when you sketch half of the graph, sine half x, it means half of the graph. Just this part, half of it, it will be just the first part of the graph here. Okay, that means, and this is sine 1x. Okay, so let's see here. Maximum is 1, minimum is -1. There is a 2 here. This 2 means that the amplitude. Okay, so now instead of amplitude 1, it becomes 2. So which means I will sketch this green graph, but my maximum value becomes 2. That is my 2 sine half x. So which means I will get this. Okay, this is my graph. So here is my y equals to 2 sine half x. So obviously from here we know that there is one intersection point. So just write down there is only one intersection point between two graphs. Hence, only one root in the interval 0 and pi. Okay, so done for this part. Now show by calculation that this root lies between 1 and 1.5. Okay, so how do we show? We have to refer back to the equation just now. So now, when you show, you have to check the graph. Okay, your intersection point is after the reflection. See here, initially it was here. So I reflected it. So for your information, this part is negative of the original value because supposedly negative, but I reflected. So when you calculate when you show the root lies between two values, we need to use this equation to solve instead of the modulus of x minus 2 or instead of x minus 2. Okay, because that is the intersection point between the reflected line and the sine graph. So I will write negative x minus 2 equals to sine graph. That is to find the intersection point. But now I need to use the sign change rule to show the root lies between 1 and 1.5. Therefore, I need to form the equation first. Or I need to form the function. So when I multiply this minus to the bracket, it will be minus x plus 2. That equals to 2 sine half x. And I will move the sine term to the left side to form a function. Okay, once you get 0, that means I will let the terms on the left side be fx. And now, show these two values by using the sign change rule. So I will just replace. But when you do calculation, you have to be careful because your function has sign. So make sure you change the mode of the calculator to radians. So then you will be getting 0.0411 and this is greater than 0. So the other one, f1.5, is going to be negative 1.5 plus 2 minus 2 sine half times 1.5. Then this is going to be negative 0.863 and less than 0. So from here, you will just write since f1 greater than 0 and f1.5 is less than 0, there is a sign change. Hence, the root lies between 1 and 1.5. Okay, so done for this, part B. See, Use the formula with an initial value of 1.03 to calculate the root correct to 2 decimal places and give the results of each iteration to 4 decimal places. So the formula is given. And then the initial value is given, so let it be x0. So I will write x0 is 1.03. Now your x1 equals to 2 minus 2 sine half of 1.03. Now, when you do calculation, make sure this is in radians mode and iteration for decimal places. It will be 1.0149. Now, when do we stop? Since the answer is 2 decimal places, if you want to stop, you must get similar value or identical value after you have round up the third decimal place. Okay, so obviously they are not equal. That means we have to continue. So this is going to be 1.0281, and when you compare 0, 1, 0, 2, even you round up, the next value is 1.03. So we need to continue for x3. This is going to be 1.0166, and again they are not equal because when I round up here it becomes 1.02, but the previous one 1.03. So just continue. Now I get 1.0266, and when I round up it is 1.03. Okay, so now x5, this is 1.0179. So 1.0179, when I round up 1.02. Okay, so the previous one 1.03. So now better continue. This is 1.0255. Again, this is 1.03 if I round up to 2 decimal places. So we need to do a lot of calculation for this question. Okay, so when you refer to here, 1.0188. So when you round up, 1.02. But the previous one, it will be 1.03. So x8. This is 1.0247. So when you round up, 1.02. Okay, so now to double confirm, so you can just find x9 because the previous one when you round up 1.02, here 1.02. So you can just find one more to double confirm the value. And now you are getting 1.0195. So when I round up, I get 1.02. So that means we can stop. So your x approximate to 1.02. Okay, this is the solution of this question. Next question, number 7. First part, or part A, express 7 sine theta plus 24 cos theta in the form r cos theta minus alpha, where r is greater than 0 and alpha is defined from 0 to half pi. Give the value of alpha correct to 4 decimal places. Okay, so look at here, this is cos, but the first one is sine. Okay, for your information, if you need to get cos, right, it should be a cos theta plus b sine theta. Then it will be r cos theta minus alpha. When here cos, the first one must be cos. And this is minus, then the other side must be plus. Okay, that's the rule for the cos. So which means now here I need to rearrange. So I will write 24 cos theta plus 7 sine theta equals to r cos theta minus alpha. So my A is 24 My b is 7. So therefore my r is going to be square root of a squared plus b squared. That is going to be square root 24 squared plus 7 squared, end up with 25. Okay, then my alpha is going to be arctangent b over a. So this is arctangent 7 over 24. And now look at here, your alpha is between 0 and half pi. That means it is in radians. So change the mode of the calculator into radians and give the alpha to 4 decimal places. Therefore, this is 0.2838. So at last, 24, I will write 7 sine theta plus 24 cos theta equals to 25 cos theta minus 0.2838. So done for the A. Now B, hence solve the equation. So when you compare these two terms with the first part, or with the part A, obviously your theta becomes 1 over 3x. Okay, so theta is 1 over 3x. Therefore, 25 cos, for the right side, 1 over 3x minus 0.2838 equals to 24.5. And now we need to solve the x from 0 to pi. So now, first of all, you need to make the coefficient for cos 1. Okay? So that means I divide the whole equation by 25. You will get cos 1 over 3x minus 0.2838 equals to 24.5 over 25. Then you will be getting 0.98, and this will be the cos of the whole angle. Now, we need to form the new interval because you are given x between 0 and pi. Now, I need to find out if 1 over 3x minus 0.2838. So first of all, I get the interval for 1 over 3x. So you times 1 over 3 to the left and right side. That will be pi over 3 for the right side. And now minus, each of these minus 0.2838. So the 0 minus that value, it will be a negative value. Pi over 3 minus that value, that is going to be 0.7634. Okay, so now we need to solve this equation. The cos of the new angle is 0.98. So now I will get the basic angle first before I draw the quadrant. Basic angle is arc cos 0.98. Okay, let's go back to the question. Hence solve. Alright, so I need to get more decimal places or more significant figures. So I give 4 significant figures because the angle is in radians. And this is my working. Now I will draw the quadrant. Okay, the cos is positive. That means it is in the first and last quadrant. Now you check. My basic angle is 0.2003. Okay, 0.2003 is within the interval. Here is less than 0.7634. And if I consider the negative value, it is bigger than this value as well. So that means I will consider one is positive, another one is negative. Okay, therefore, I will say, oh, this is not yet my final answer. I will write 1 over 3x minus 0.2838. It will be positive 0.2003 and negative 0.2003 because both values will be in this interval. And now we need to find x. So firstly, the negative 0.2838 will be moved to the right side. Okay, because we need to find x. So this term move to right side becomes plus. So 1 over 3x 0.2003 plus 0.2838, that is 0.4841, and the next value is 0.0835. So now times the whole equation by 3. I mean not whole equation, all the values. So you will get 1.4523 and the other one is 0.2505. Now final answer always round up to 3 significant figures if the angle is in radians. So now I will be getting 1.45 and the other one is 0.251. Okay, so done for this question. Next question, number 8. The variables x and theta satisfy the differential equation. So sine 2 theta dx d theta equals to 4x plus 3 times cos 2 theta, where the x goes to 0 and the theta is 1 over 12 pi. Solve the differential equation and obtain the expression for x in terms of theta. That means x as the subject. Okay, so rewrite the differential equation. Now we need to separate the variables. So by looking at this, because of dx d theta, that means your dx should be on the left side, d theta should be on the right side. So this 4x plus 3 move down, becomes 1 over 4x plus 3. And then the sine 2 theta will be moved to right side. So cos 2 theta over sine 2 theta. After that, integrate both sides. Okay, so now for the left hand side, since it is rational function and the 4x plus 3 with degree 1, I'm going to use the ln formula. Ln formula is integrate over fx. The numerator is f prime x. This is going to be ln fx plus c. Okay, so when I differentiate 4x plus 3, I should get 4. So to get back 1 from 4, I have to times 1 over 4 outside. Now for the sine 2 theta, if I differentiate sine, I get cos 2 theta remains. Differentiate 2 theta is 2. This is my differentiation. So to get back the previous, I got to times half outside. Okay, therefore, the left hand side integration is basically 1 over 4 ln of 4x plus 3. The right hand side is half ln sine 2 theta plus c. I put a modulus for the ln because ln must be ln of positive value. Okay, so now replace the values. X is 0. Theta is 1 over 12 pi. That means now here I will be getting 1 over 4 ln. 4 times 0 is 0, then plus 3, that is ln 3. Then it will be equals to half ln sine, 2 theta. 2 theta is 2 over 12 pi, that is pi over 6 plus c. Okay, then now here to get the c, I will get 1 over 4 ln 3 minus half ln, sine pi over 6. This is half. Okay. And then from here, you can just leave your answer in this form. And then now I will substitute this c into this result. So I will get 1 over 4 ln 4x plus 3 equals to half ln sine 2 theta plus 1 over 4 ln 3 minus half ln half. Okay, so by looking at this, look at the answer, look at the question first. You need to get x as a subject because x in terms of theta. So Now I have 4x, but before that I have 1 over 4 here. So I times the whole equation by 4. Therefore, ln of 4x plus 3 equals to 2 ln sine 2 theta plus ln 3 minus 2 ln half. Okay, since we have so many ln here, before we simplify the ln, right, we need to make it 1 ln on both sides. So at the same time, to group all the ln on the right side, since you have the coefficient, so what I need to do is probably I will just use a ln b equals to ln b power a. After that, ln a plus ln b, you can simplify into ln ab, and followed by ln a minus ln b, that is ln a over b. So the first one is to make it to coefficient of 1 for the ln first, before you can combine. So which means now here I will get ln, okay, now I will just write bracket because I'm going to square it, then plus ln 3, this negative 2, this 2 you can move up, okay, so it will be negative ln half power 2, right? So you can leave it as negative ln half power 2, or probably you can change to plus, up to you, because the 1 over 2 is basically 2 power negative 1. Okay, if you want to do that, so probably I will just write like that. Here is going to be 2 ln 2 power negative 1, then the minus 1 you move down. Okay, so here more steps. This is plus 2 ln 2, then the 2 move up. So it all depends on you, right? So for the first two terms, I can combine first because of the second formula, because 3 sine squared 2 theta, and then this is plus 2, these 2 move up using the first formula, that is 2 power 2, that is ln 4. And now you combine. So basically this becomes ln of 3 sine squared 2 theta times 4, that is 12. Okay, since you have found 1 ln on both sides, which means now here I will just ignore the ln, cancel off the ln from both sides. So 4x plus 3 equals to 12 sine squared 2 theta. Another question asking for x as a subject, which means the plus 3 move to right side. So 4x equals to 12 sine squared 2x minus 3, and divide the whole equation by 4. So your x is basically 12 sine squared 2 theta minus 3 over 4. You can leave it in this form, or probably you can just split it into 2 terms, so that the first term 12 over 4 is 3. So 3 sine squared 2 theta, and the second term is minus 3 over 4. This will be your final answer. Alright, so next question, number 9. With respect to the origin O, the points A, B, C have the given position vectors. Find the vector equation for the line through A and B. Okay, so for your information, if let's say this is the line through A and B, okay, the direction vector is either in AB or in BA, in the direction of AB or BA, up to you. So the line, we need to write down a fixed point. So or probably I will just find out the AB first. Okay, so that is my direction vector. AB is OB minus OA. So OB is given. OA 1 minus 4, 2. So when you simplify, minus 2 minus 1, that is minus 3. 1 minus minus 4, that is 5. The last term, 3 minus 2 is 1. This is my direction vector. So now for my vector equation, of the line AB. Alright, R equals to, now you have 2 points. You can either let the A be the fixed point or the B be the fixed point. So I will write OA plus TAB. So my OA, 1 minus 4, 2, plus T of minus 3, 5, 1. So this is my vector equation of the line AB. Now using a scalar product, find the exact value of cos BAC. Okay, so now here, cos BAC. So just now we found AB. Okay, C. Let's say this is a point C. We have found the line AB. So exact value of cos BAC is over here. That means now based on this, we need to get the vectors of AB and AC so that the theta is the angle bounded by these two vectors, and using scalar products formula, which means now here I need to find out what is my AC first. AC is basically vector OC minus vector OA. Okay, so vector OC 2, 3, 5 minus my A is 1 minus 4, 2. Then from here, 2 minus 1 is 1. 3 minus minus 4, that is 7. 5 minus 2 is 3. Okay, I have found the vector AC. And based on this diagram, okay, so my scalar products formula, AB dot AC equals to magnitude AB, magnitude AC, cos BAC. Okay, now I need to calculate my magnitude AB and magnitude AC. So your AB dot AC, your AB is minus 351. Okay, minus 351. So now AC 173. The modulus, square of each number and plus. So the left hand side, it will be minus 3 times 1 plus 5 times 7 plus 1 times 3. And then the first square root is basically square root 35. The second square root is square root 59. And then cos BAC. So the left hand side, minus 3 plus 3, the first and last term will be 0. So I will get 35 equals to square root 35 square root 59 cos BAC. Okay, now let's see the question. You need to calculate exact value of cos BAC. Okay, so I will just get the cos BAC as the subject. So it will be 35 over square root 35 square root 59. So the 35, okay, because you have a square root 35 in the denominator, I will just split it into multiplication of square root 35 and square root 35 instead of just writing 35. Then you can cancel off the square root 35 in the denominator. And now you have division of two square roots, therefore I can just combine them. This will be my exact value. Okay, done for this angle or cos BAC. Hence, find the exact area of the triangle ABC. Okay, go back to this triangle. Maybe I just redraw. So, cos BAC is found. So, now, area of triangle ABC. Since we know this angle, I will say we use this formula. Area of the triangle is half AB sine theta. Okay, so which means I have found this angle, or I have found the cos of this angle in the previous calculation. So as long as I know these two sides and the angle, then I will be using the formula. The sides here means the magnitude. So half magnitude AB, magnitude AC, sine BAC. Okay, so the magnitude AB and magnitude AC we have found just now. Magnitude AB, magnitude AC, square root 35, square root 59. So which means now here I will write square root 35 and square root 59. Okay, for the sine, we need to use identity formula. Sine square theta plus cos square theta is 1. So your sine theta is square root of 1 minus cos squared theta. Right. So which means now here I will write square root of 1 minus cos squared BAC. Therefore, this is half square root 35 square root 59 square root 1 minus square of this. Okay, then now when I calculate the sine, this is square root 24 over 59. So from here, I can split Okay, look at the question. You need to find exact area. Exact area means no decimal. So this is square root 24 over square root 59. So the square root 59 can be cancelled off. Right? And then this square root 35 times square root 24, that is 2 square root 210. So the 2.5 can be cancelled off. Square root 210 is your final answer. So this is our exact area of the triangle. Okay, question 10. Find the quotient and remainder when x squared is divided by 1 plus 4x squared. Okay, so this can be found using the polynomial division, or what we call as long division. Okay, so x squared divided by 1 plus 4x squared, or I will write 4x squared plus 1. So to get x squared from 4x squared, I need to times by 1 over 4. So I better write plus 0x plus 0 first. So I times by 1 over 4. So 1 over 4 times 4x squared, that is x squared. 1 over 4 times plus 1 is plus 1 over 4. Then subtract. So obviously, you will be getting 0 minus 1 over 4. That is minus 1 over 4. So our quotient is 1 over 4. This is our quotient. And here is our remainder. So done for this part. Now B, find the exact value for the integration. Okay, so to integrate this, when you look at the function, it is product of two different types of functions. This is algebraic. The first one is algebraic. This is inverse trigo. Okay, two different types. Therefore, we need to use by parts formula. So when by parts, now integration by parts. Integrates u dv dx. This is uv minus integrates v du over dx. Now, your u is based on this. Based on this rule. Okay, L is ln, I is the inverse trigo, A is algebraic, T is trigonometric, E is exponential. So therefore, in this case, I have the I, which is inverse trigo function. Therefore, my U is arctangent. Okay, so I will just write here, let's U equals to arctangent to x, and then my dv dx is going to be x. So now, when you use the formula, when you differentiate arctangent, our formula in the formula list is differentiate arctangent x over a. That is a over 1 plus a squared plus x squared. Okay, that is your formula. So what I need to do is, okay, so wait, let me write. This is x, so 1 over 1 plus x squared. Right? So now, if here is x, you get 1 plus 1 over x squared, but this is 2x. So if it is 2x, then you have to differentiate. Okay, so it will be over 1 plus 2x squared. You assume the x becomes 2x, but then instead of 1 here, you got to differentiate the 2x. So when you differentiate 2x, that is 2. Okay, so here is 2 over 1 plus 4x squared. Even though it is not x squared, it is not x, then you just do the assumption, but then don't forget to differentiate the x, the 2x. So then the v will be integration of x dx. Then you will be getting x squared over 2. So now, this is going to be uv, okay, according to by parts. So I will write x squared over 2 arctangent to x with limits 0 to 0.5 minus integrate v du. So here you multiply. And solve the first part by replacing the limits. So 0.5 squared over 2 arctangent 2 times 0.5 is actually 1. Then minus, when x is 0, everything is 0. Okay, then minus, simplify. The 2.5 cancel off. So I will be getting 0 to 0.5, the integration, the limits, x squared over 1 plus 4x squared. Now, arctangent 1 is pi over 4. 0.5 squared is 1 over 4. 1 over 4 divided by 2, 1 over 8. Then pi over 4. Okay, then minus, integrate 0 to 0.5. This is division. Okay, we have done it in the previous step. X squared divided by 1 plus x squared. That's why you have done the quotient and remainder here. My quotient is 1 over 4. Okay, remainder negative 1 over 4. So I will get 1 over 4 minus remainder is 1 over 4. Remainder is minus 1 over 4. Okay, so when I write, it will be negative 1 over 4 over 1 plus 4x squared. And now from here, the first term, when you multiply, that is pi over 32. So now I split into two integrations. So integrate 1 over 4, 0 to 0.5, Probably you can just write 1 over 4 inside the square root, inside the integration sign. Okay, this is my first integration. Second integration, you have to be careful. Minus minus is a plus. And this 1 over 4, you can take it out. So I will write plus 1 over 4. 1 over 1 plus 4x squared. So rewrite the first term. Integrate 1 over 4, it will be 1 over 4x. Okay, but now here, when you check this, integration of 1 over 1 plus x, 1 over 1 plus 4x squared, it will be similar to this, right? See? When I differentiate arctangent 2x, I get 2 over 1 plus 4x squared. So if I integrate 2 over 1 plus 4x squared, I will be getting arctangent 2x. So what I need to do here is probably I will just write integrate 2 over 1 plus 4x squared dx is arctangent 2x plus c. So now here I integrate 1 over 1 plus 4x squared. So these two, I will move it out and move down to the right side. Okay, so which means 1 over 1 plus 4x squared dx is half arctangent 2x. Okay, so I will write here, this is half arctangent 2x. And now here we don't plus c because of the limits. Right, because the integration is the reverse process of differentiation. Then now you just replace all the values. The 0.5 I can change to half minus 0. Okay, let's look at the question. The question asking for exact. Exact means no decimal. So, but then we can leave it in fraction, no problem. Okay, so then this 1 over 2 I move out. So it becomes plus 1 over 8. Arctangent 2 times half is 1 minus arctangent 0. So here becomes pi over 32 minus 1 over 8 plus 1 over 8 bracket. Arctangent 1 is pi over 4. Then arctangent 0 is 0. Okay, this is 0. So I will just close bracket and now simplify. So the first one pi over 32. The last one is pi over 32. So when you add up both of these, the first and last term, it will be pi over 16. Then minus 1 over 8. So this is your exact area of the integration. Okay, now we move on to question 11. The diagram shows the graph of y equals to 5 sine 2x cos square x for x between 0 and half pi and its maximum point m. Find the exact x coordinates of m. Exact means no decimal. Since the m is the maximum point, that means now I need to differentiate and let it be 0. So your y is 5 sine 2x cos square x. I will change this into 5 sine 2x as one term, cos x squared as a second term. And then I apply the products rule because this is multiplication of two terms. So now my u equals to 5 sine 2x. My v is cos x squared. Now according to the products rule, differentiate uv prime plus vu prime. Okay, so your u prime and v prime will be the du dx and the dv dx. So now u prime, when I differentiate 5 sine 2x, I will write 5. The sign change to cos, remain the 2x. Differentiate 2x is 2. Therefore, I'm getting 10 cos 2x. For the v, when you differentiate, we need to apply this formula. Differentiate fx degree n, the power rule. It will be n fx degree n minus 1. Differentiate fx, f prime x. Okay, which means now here, I bring down the power 2, remain cos x, the degree becomes 1. 2 minus 1 is 1. Differentiate cos x minus sin x. So when you simplify, this is minus 2 cos x sin x. Okay, and now I will write my dy dx equals to u v prime. So 5 sin 2x minus 2 cos x sin x plus vu prime cos square x times 10 cos 2x. Okay, so from here, I will simplify. 5 times minus 2, that is minus 10. Okay, then because you have sine 2x, see here, 2x, 1x, 1x, then here 1x, 2x. So better change all into just 1x. Okay, because later we need to solve the equation. So now use another formula. Sine 2x is 2 sine x cos x. And the other one is cos 2x. So for cos 2x, we have few formulas. So here it will be cos square x, 2 cos square x minus 1. 1 minus 2 sine square x, or probably cos square x minus sine square x. Okay, we have 3 forms. So later we will choose which form is suitable for this. So here I will change this sine 2x into 2 sine x cos x. And then here, sine and cos. Okay, plus the 10, rewrite first. Cos square x. Okay, then now here, the cos 2x, I will change, okay, because here, cos square x. Sine square x. So the cos 2x, I will change to 2 cos square x minus 1. I simply choose 1. Okay, then here you will be getting the, okay, let me check. I will factorize the cos squared because here you have cos squared. And at the same time, the 10 also will be taken out, factorized out. Okay, so which means I will factorize 10 cos square x. Then remaining terms will be minus 2 sine and the sine. So minus 2 sine square x. Okay, then I will just copy this. Which means now the sine square x I need to change. Okay, so otherwise you can just use 1 minus sine square x minus 1 minus 2 sine square x for the cos 2x. It's up to you. So here I will write cos square x plus sine square x is 1. So my sine square x, it will be 1 minus cos square x. So change this again. Okay, let me check. Okay, then now here, just simplify. Then you will be getting 10 cos square x. So it depends on you whether you want to express a square bracket in terms of cos or sine. So later will be the same answer. Okay, then from here, you will be getting 10 cos square x. So 2 cos square plus 2 cos square, 4 cos square x. Okay, I leave it in cos. minus 1 minus 2 minus 2 minus 1 is minus 3. Okay, so once I have simplify this, my maximum points means when dy dx is 0. Okay, that's why I simplify up to this form just now. So just rewrite n equals to 0. So now, when multiplication of two terms equals to 0 means one of them equals to 0, which means now probably I will let cos square x equals to 0. Or 4 cos square x minus 3 equals to 0. So when cos square x equals to 0, obviously your cos x is 0. So when cos x equals to 0, okay, look at the cos graph. Here will be 0. This is 2 pi. That means this is 3 over 2 pi. Here is pi and pi over 2. So your x will be pi over 2 and 3 over 2 pi. Okay, but then look at the graph. Your m is between 0 and half pi. Right, so your m is between 0 and half pi. That means just now the cos x equals to 0. Okay, so we get two values there, pi over 2 and 3 pi over 2. Both are not accepted. Okay, so not accepted. That means we have to solve from the other one. The other one is 4 cos squared minus 4 cos square x minus 3 equals to 0. So which means now here I will have to write cos square x equals to 3 over 4. Then my cos x will be plus minus square root of 3 over 4. So this will be, okay, plus minus. So which means now your x is between 0 and half pi according to the graph. So my cos x should be positive value. Okay, because this is in first quadrant. So when it is square root of 3 over 4, basically your x is going to be at cos. This is pi over 6. So which means my x is pi over 6. This is my exact value for the m. Okay, now b, use the substitution u equals to cos x. Find the area of the region bounded by the curve, the x-axis, and the lines. Okay, everything is given. So your area is basically integrate from 0 to pi over 4, 5 sine 2x cos square x dx. Okay, then from here, we need to integrate sine 2x and cos square x. So I change the 2x into x first. So which means it will be 2 sine x cos x and then cos square x dx. So from here, you will be getting 10 integrate 0 to 1 over 4 pi sine x, the cos and cos power 2, cos power 3. So when we need to integrate sine and cos, we may use substitution, and hence already given here, your u is cos x. So now here, I will write my left side. Okay, I differentiate the u with respect to u, and then I differentiate right side, the cos x with respect to x, okay, which is minus sine x dx. And then I have sine x dx. So I will write sine x dx equals to negative du. At the same time, the 0 and half and 1 over 4 pi. So when x equals to 0, your u is cos 0, that is 1. When x equals to 1 over 4 pi or pi over 4, your u is cos pi over 4. Cos pi over 4 is square root 2 over 2. Okay, the question asking for area. So now here becomes tan integrate from 1 to root 2 over 2. So the sign together with the dx will be changed to minus du. So minus du. The cos cube x will be u cube. So here I will get negative tan. Integrate u cube is u degree 4 over 4. Limits 1 to root 2 over 2. Okay, then here just factorize the 4. So minus 10 over 4. And replace the u. So root 2 over 2 power 4 minus 1 degree 4. So at last, you will be getting 15 over 8. So this is the area of the bounded region. Okay, so with this, we have completed this paper. Thanks for watching. If you enjoy watching my video, please subscribe to the channel and share this channel with your friends. And stay tuned for more upcoming videos. Thank you everyone. Bye.